We have assembled to talk about an important tool in the analyze phase, the scatter plot, scatter analysis, followed by the improve phase and control phase. That will complete our the pending modules for the first level of learning with respect to the DMAC. I suggest all of you to be interactive, right? You can even keep your camera on and you can be interactive, right? So make it as effective as the classroom session. Okay. So with that note, I'm sharing my screen. Let me straight away go to the scatter plot. So we'll be focusing more on the basics. When we meet in the classroom, we are going to have more like activity based learning of the similar tools, right? Same scatter plot. We'll do it using Excel. We'll do it using Minitab. All right. So I have shared my screen. I'm putting it in presentation mode. Hope everybody can see my screen, right? Screen is visible and my audio is properly audible. Is that correct?
Yes, sir.
Yeah.
Yes, sir.
Okay. So scatter plot as well as the correlation analysis. So, in a broader sense, your scatter plot can help you to study the relationship that may exist between your x variable and y variable. X variable, we know they are input factors. Here we call them as predictors. Y variable, the output factor, here we call them as response variable. So the question we are trying to get answered is there a relationship between the predictor variable and the response variable? So for that, we are going to understand the scatter plot and then correlation analysis. Like, so correlation means quantifying the linear relationship, quantifying the strength of linear relationship between an x variable and a y variable, known as the predictor and the response variable, respectively. So, a typical scatter plot is nothing but a graph showing the x variable in the horizontal axis, the y variable in the vertical axis. The requirement is the x variable and the y variable. Both must be continuous in nature. You all know continuous. Continuous means it is measurable. It has an unit of measurement. Only such variables can be plotted in scatter plot very well. And then you can interpret the relationship accurately, right? So the requirement is both predictor and response variable, both must be of continuous data. For example, speed versus mileage. Speed will be represented in the x-axis, mileage will be represented in the
Y axis.
measured in kilometer per liter. So both are measurable, so scatter plot is possible, and we can have a meaningful study of the relationship between x and y. If you look at the graph right now, I'm showing in the screen this one. This is predictor, this is response. For different values of x, these values you have to select carefully according to the current range of operation of the x. According to the current range of operation of the x. You can also call it range of investigation. So different values of x within the current range of operation are selected, and at each value of x, the y variable is recorded. It's a kind of experiment we need to do. Set your x at different values within the range of investigation. Then at each value of x, what is the value of y that is getting recorded? That value you must mark in your graph sheet. Now all the red color dots represents the experimental value of y corresponding to the different values of x. Hope all of you could follow me in this. And now we understand after plotting all the points or all the values of y variable, I am happy to note that the y variable, the points of the y variable when plotted forms a pattern or forms a linear pattern. Isn't it? It looks like a straight line. So we could conclude that there is a linear relationship between x and y. The first information. It looks like a straight line. In fact, it's a perfect straight line. You can see that. It's not just looking like a line, it is actually a perfect straight line. So our conclusion is x and y are linearly related. Moreover, I could also understand as I keep on increasing the x, my y also keeps on increasing. So it is not only linear, it is linear positive. Over and above, the points are forming a perfect straight line. So it's not only linear positive, it is perfect linear positive relationship. Hope all of you are with me on this. This is a case of perfect linear positive relationship. Now, another case. Here also I see a perfect line. Here also I see a linear relationship. But one difference what I could notice here is as I increase the x, my y is decreasing. You can see that. As I increase my x, my y is decreasing. So the relationship is perfect negative relationship or perfect negative linear relationship. The linear relationship can be simply called as correlation. Correlation means linear relationship. Now I'm showing another graph. And this time, the line is not a perfect line. You can see the points are not forming a perfect line. You can see here, it's going up, down, going up, down. Forming a perfect straight line is a hypothetical case. It's too theoretical. But in real life, you don't get the perfect line. It's just, always it goes up and down, right? And so I will not use the word perfect here. Instead, I would like to say the relationship is strong or very strong. Very strong means each and every point will be very close to the straight line which we are imagining here. Which we are actually the points are not following a line, but we simply assume the points are following a line like this. But the reality is points are very, very closer to the assumed line. Assumed line, right? This assumed line represents the relationship between x and y and is known as the regression line. And is known as the regression line. Since the points are very, very close to the regression line, you can say the relationship is strong or very strong. But however, the relationship is always positive. You can see, you can understand. As I keep on increasing my x, my y is going up. So, strong positive. Now, if you look at the fourth graph, where the x variable is modified, y variable is recorded, but I am not able to identify any relationship between x and y. The y values are completely scattered with respect to the fourth graph. So I conclude there is no correlation. There is no correlation and there is no relation. Hope all of you are able to understand the four different types of relationship here that exists between X and Y. Now, now, if I again show a graph, what do you think, all of you? Is this relationship is perfect, linear, positive, or negative, or what is your opinion? It is definitely, it is not,
Perfect.
yeah, it's not perfect because perfect means everything should fall on the regression line. That's not happening. So it can be either strong or very strong. So in order to eliminate the difference in the opinion, because somebody can say it is strong, another person can say it is very strong. In order to rule out this confusion, a formula is introduced. You can see here a formula. The formula is known as Pearson correlation coefficient, R, where R is equal to 1 by n minus 1 summation of x minus x bar divided by Sx multiplied by y minus y bar by Sy, where n is the number of data points, x bar is the average of x values, y bar is the average of y values, and Sx is the standard deviation of your x variable, Sy is the standard deviation of your y variable. If you can manage to calculate all of these things, then value of R will be obtained. The formula is designed in such a way that the value of R will vary between minus 1 and plus 1. Will vary between minus 1 and plus 1. So minus 1 refers to minus 1 or plus 1, both refers to perfect relationship. Minus 1 means perfect negative, plus 1 means perfect positive. Like the diagram 1 and 2 I have shown in the previous slide. When the situation 1 occurs, R will be equal to plus 1. When situation 2 occurs, R will be equal to minus 1. Perfect negative, right? And, uh, and also, if perfection is not happening, your R will start varying from 0 to minus 1 on the negative side, 0 to plus 1 on the positive side. So 0 to plus 1 is strong, or 0 to plus 1 is positive correlation, 0 to minus 1 is negative correlation, right? So within 0 to plus 1, you see some division. Up to zero point 0.4, we call the relationship or correlation as weak. Zero point 0.4 to zero point 0.7, we call it moderate. Zero point 0.7 to 1, we call it strong. Similarly, on the negative side also. So in this case, this is actually a strong positive. If you calculate R value will be between zero point 0.7 to 1. So we'll see that. And now all of you look at the screen and tell me, what do you think about this relationship? Is it strong, moderate, or weak? It looks to be closer, right?
Positive.
Yeah. Is it
Strong.
definitely positive?
Positive,
Definitely.
strong.
Yeah, positive and strong. That is confirmed by the R value here. You see, 0.917. R is calculated. This is strong positive. And this one is
Negative. Is
Strong
Strong
negative.
strong
negative.
negative.
strong negative. This one is strong negative. Strong positive, strong negative. And this one,
Weak, sir.
Moderate.
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 look at the
Moderate
R here.
positive.
Look at the R here.
Weak, sir.
0.255. That means weak positive.
Weak. Weak positive.
Weak positive. And this one is weak negative. This is the application of correlation coefficient, the value of R. Calculating R can be helpful in defining the relationship. Now the third set of example. Now, what do you think? What will be the relationship here? Do you notice any relationship here?
No.
No
No
correlation.
relationship.
So then, what will
No
be the R
correlation.
value in this? What will be the R value in this case?
Zero.
R value, very good. R value in this case will be 0. You can either say no relationship or you can say no linear relationship. No linear relation means no correlation. Now the last diagram. Now what do you think here? Is there a relation?
No relation.
There is a curvilinear relation. There is a relation. But there is no linear relation, but there is a curvilinear relation. There is no correlation, but there is curvilinear relation. This curve is known as parabola. You can either say parabolic relationship or you can say quadratic relationship. So no correlation, no relationship for this case. Whereas for the last case, there is no correlation, but there is parabolic or quadratic relation. There is parabolic or quadratic relation. Let's continue. So there is relationship. Just a second. So we understood the scatter plot. So scatter plot is a graphical tool used to examine the relationship between two continuous variable, and correlation analysis is a statistical technique to measure the strength and direction of the linear relationship associated between two variables. Correlation can be any value between -1 and +1. Correlation can be any value between -1 and +1, and 0 to -1 refers to negative correlation, 0 to +1 refers to positive correlation. So the more the R value, more the strength of linear relationship. So yes, it ranges from -1 to +1. Positive values indicate positive relationship, negative value indicate negative relationship. Values closer to 0 indicate a weak or dubious relationship. Value closer to 1 indicates strong or perfect relationship. So I think the correlation coefficient and the scatter plot is understood. If there are any questions, please feel free to ask. Are there any questions here on scatter plot? All of you? Scatter plot is one of the 7 basic quality control tool. So this tool can help you to understand the relationship. So before generating a solution, knowing the relationship is a good idea, right? So before going for the solution generation discussion, the brainstorming session, you can actually do some study about the relationship. And because if the relationship is known, you can actually optimize your X variable accordingly. If the relationship is known, you can actually optimize the X variable accordingly. Yeah, you can actually optimize the X variable accordingly. Okay, so that means we can proceed further, right? Okay, so the scatter plot is clearly understood.